First thing I'm going to do is just write out the left and the right hand side of the actual equation. This proof is an example of a complex fraction. So what that means is it's going to have a fraction within a fraction, and I'm going to show you my method of dealing with it. Okay, first thing I'm going to do, change everything to sine and cos. So secant becomes 1 over cos, tan becomes sine over cos. Right hand side is just sine theta. There's really nothing to do. So what makes this a complex fraction is that it's got fractions inside of a fraction. So what we want to do, or what I typically do, is I want to get rid of that. I want to get rid of the complex fraction and just make this a simple fraction. How I do that is I'm going to multiply top and bottom by the common denominator of whatever fractions are inside the fraction, which in this case, both denominators are cos. So cos theta is the common denominator, so I'm going to multiply the numerator and the denominator by cosine theta. So the top cosine is multiplying by both terms in the numerator. The bottom cos is multiplying by whatever is in the denominator. So 1 over cos times cos is 1 minus cos times cos is cos squared. So that's why it's 1 minus cos squared in the numerator. Cos times sine over cos, the coses just cancel. So all we're left with is sine theta. 1 minus cos squared is a Pythagorean identity. So 1 minus cos squared equals sine squared. So this becomes sine squared divided by sine theta. The sines cancel, and we're left with just sine theta, and left side equals right side, and we're done.